Hello and welcome to Physics for the 21st Century. Again, my name is Greg Perugini, and today we're going to be talking about Hooke's Law. So that is our topic. Hooke's Law is a fairly straightforward equation. We have force as a vector, and it is a restoring force, that's why there's a negative sign there, to K times X. So what is K and X? Well, K is the spring constant, and X, sometimes change of X, is the distance that you will be compressing or decompressing a spring. So the greater that K value is, the stronger the spring. So if I am taking a spring and I'm stretching it, I have to do a force to stretch it. The spring itself wants to restore back. Now we're going to be talking later on about energy, but know this, that when I've stretched the spring and I'm holding it there, there is a potential energy in the spring. Now, when I stretch that spring, as you can see in this picture, as you might guess, I have this linear relationship as with the equation up to a certain point. If I go further than that point, well, not everything has a perfect linear elasticity. It would either break like a rubber band if I was stretching a rubber band, or the spring would be reaching a point where it would not be perfectly elastic. There is that portion where it would not obey Hooke's law. But in this bit here, it's going to obey Hooke's law. As always, it's good to show a little example here. So, just like in the picture, I have a spring, and that's its normal position, and I put on additional weight, let's just call that the normal, of 300 grams. And that 300 grams stretches it an additional, let's say 7.5 centimeters. What is the spring constant? Well, if we look at the equation, what is the force that's happening here? Well, that's the force of gravity, right? 0.3 kilograms, have to be in SI units, times 9.8. That is equal to negative force downward, kx, where x, distance, is 0.075. Well, if I solve that equation, what do I get? K is equal to 38.7. And if you look at that, that's in Newton per meter. So that's the spring constant. Now suppose I put an additional weight on there, and that's just a simple thing. Now I am at another additional, so I'm at 500 grams. Of course, that's going to be the question here would be, how far does it stretch? We already know K, right? So I can write down force is equal to .7. We're trying to get the K value. And we know the force is 0.5 times negative 9.8. How far does it stretch? From that initial point here, this distance, if you do your math, it's about 13 centimeters, 0.13 meters. Now, you also might get a problem that asks for work. How much work was done? Well, we know that work is force times the distance. That force is done over. We know this distance here, in this case, is 0.13. The force is 0.5 times 9.8. Okay, and that's 4.9. So the work done is 0.64 joules. The work done by gravity in the downward direction. So in conclusion, check your work, understand these equations, know that force is a restorative force, watch your significant figures, and practice your assessments. Practice before the assessment, and good luck.